Hi everyone, welcome back Fluid Mechanics. In this example, we are reviewing a curve gate behind a dam, which is a sector of a circular curve. And if we know what are the widths of the gate and also the radius of our section, we want to know what is the resultant force applied to the gate from the water. So to start our problem, we you can see the dimensions like the height of water, which is 10 meters, radius of our section is 20 meter, and this theta, which we can easily calculate it based off the dimension provided. And if we want to calculate the resultant force, we can solve it from two approaches. The first one is the integration approach, uh, which is the material for this video, and in the next video we are solving it with the geometry approach. So in the integration approach, which is the classic approach, if you just consider a small portion of this sector, the total angle is theta, the small part is d theta. So if this is r, this is d theta, our length here is equal to r d theta. Mhm. And definitely our force is consist of our resultant force consists of two component in the plane like df sub h and df sub v. Differential format of force in horizontal direction and differential force in vertical for our small uh, sample. So df sub h is df cosine of theta, as you can easily see here. If this is theta, this is theta, and the horizontal component is df cosine of theta, and vertical one is df sine of theta, as you can see here respectively. But we do also know that df is force is nothing but pressure times area. So if it's in differential form, that's pressure times the differential format of area, and our PDA, and then replace the rest like it's just PDA cosine of theta. And we also know that pressure is nothing but rho gh as you sink down to the water. So, and our h, if you draw a straight line, vertical line here, this is 10 meter of water. If this is r and this is theta, you can easily conclude that this height is 10 sine of, or r sine of, my bad, r sine of theta. So we have like rho g r sine of theta, or a small elementary port, the length is r d theta, and the other dimension for area is the width of our uh, gate, which is 35 in number, or we just put it like in parametric for this w r d theta, and then finally we replace cosine of theta. And likewise, df sub v is df sine of theta. That's pda sine of theta. And if you rearrange it, you will reach to this part. Let's jump to the horizontal component of force. And we do also know the fh is nothing but integration of differential format of horizontal force. If we take all the constant behind the integration from 0 to theta, then sine theta, cosine theta, d theta, then if you look at to the problem statement, the hypotenuse is 20 meter, the vertical component is 10, so one can easily say that's sine inverse of 10 over 20, which is a half, and that's nothing but a pi over 6, or take 30 degrees in terms of a, the theta. So then you have like this integration, and then we have like integration from 0 to theta sine of theta. The uh, derivative of sine of theta is cosine of theta, so it just make it like this is the constant, and the integration part is half of sine square theta from 0 to 30 degrees. If we do the math for horizontal component and replace it in the equation, so this is like gamma, which is Rho g, rho is 10 cube kg over meter cube in SI times g, which is 9.81. W is provided to be 35 and R is 20. So our W, which is here, or width of it's provided in problem statement to be 35 meters. So a sine square of 30 is 1 over 4. So if you do the math, it just gives you FH is equal to almost 1.72 times 10 to 7 newtons. Let's move on. So far we calculate the horizontal component of the resultant force. Now we want to know what is the vertical component, which is dF sub V. And if you rearrange this equation, take the constant out of integration, it just gives us the vertical component rho g w r squared integration from 0 to theta sine square theta d theta. If you expand the integration part, it just gives you a half of in bracket 1 minus cosine 2 theta close bracket d theta. And if you do the integration, it just gives you this numeric value again. Look at the R and W widths and the radius. If you do the math, it just gives you vertical component is less than horizontal component, and that's equal to 6.22 10 to 6 newtons. So as soon as we have both component F sub H and F sub V, horizontal component, vertical component, so horizontal, vertical, then F resultant is nothing but the square root of FH squared plus FV squared. And if you do replace them in the main equation, it just gives you F sub R is almost equal to 1.83 times 10 to 7 newtons. So it was the first solution, which is the integration or classical approach to the problem. And if you want to uh, do it easier, there is a far easier approach, which is the geometry approach. That's the solution to, that's the material for the next video, and we'll solve it with the geometry as well. Thank you. Please provide me with your invaluable comments in or any recommendation in the problems. Thank you. Have a good weekend.